focused vision. To find ideas that become solutions to the world's most pressing concerns. Innovation and creativity are the sparks that ignite to transform lives and society. And these need space to grow.
We are home to these creative and innovative sparks. Our work goes beyond the disciplines, across our 9 faculties, 7 campuses, and being one of Africa's top business schools. As an African global university, we stand proudly among the world's top universities. We remain at the forefront of universal discoveries and provide authentically African solutions to the world's greatest challenges and opportunities. We are pioneers in our fields, from the humanities to cutting-edge technologies, continually seeking ways to improve the world around us. Our hybrid learning systems provide quality education that enables graduates to become adaptable game changers. We have molded nearly 500,000 alumni who have made their mark locally and internationally, and we continue to inspire and equip our students to uphold our firmly rooted culture of excellence. At the heart of what we do is our people. They are creative, critical thinkers who can shape society for the better. Because that is how we teach, learn, innovate, impact, and live. We are the University of Pretoria.
Good evening, ladies and gentlemen. It's my honor and privilege this evening to be the program director for this very special expert lecture of tonight with, I have to say it, one of my colleagues and one of the people in my faculty, which is the Faculty of Engineering, Built Environment and Information Technology. I would like to introduce our interim Vice-Chancellor, Prof. Themba Musia. He is our interim Vice-Chancellor and Principal for another month or so, and he holds a PhD in Policy Studies, particularly Governance. He earned his university qualifications in both South Africa and the United States. Prof. Musia has served the academic enterprise in numerous capacities, starting over 40 years with teaching, lecturing, international relations, head of department, Registrar, Dean, General Manager of the Health Professions Council of South Africa, Deputy Vice-Chancellor, Vice Principal, Interim Chair of the National Student Financial Aid Scheme. He served as an Administrator and Vice-Chancellor of one of South Africa's largest universities. His academic expertise is in quality assurance, governance, and health sciences education. Prof. Musia performed institutional assessments and audits and accreditations in numerous countries. He was appointed as an expert advisor to the Commission of Inquiry into the Feasibility of Fee-Free Higher Education in South Africa, and he served as the chairperson of the Council on Higher Education for 2 terms and on numerous other international networks. Ladies and gentlemen, Prof. Musia is a frequent speaker at various national and international conferences and events, and he is fulfilled by leadership training of students. Please join me in welcoming Prof. Musia to do the welcome. Thank you.
Thank you, Mr. Dean. Thank you, Professor Stein, for that introduction. You omitted the sentence there that I'm a frequent speaker, but an incredibly boring speaker. You know? So you should tell the truth, man. Yeah. Good evening, everyone. It's my honor and privilege to say something about my friend and colleague, Professor Nelishia Pillay on this very special tradition that universities have established over, I don't know, probably centuries now. And this is a platform where experts that we are truly proud of as a University of Pretoria have this public platform, and share their research on all of the developments and innovations that are quite significant. And I think there's so much I can say about her, but rather we're here to listen to her wow us here. And she is, in fact, one of the foremost experts that we have, among others, at this university. She has these big positions, a multi-choice joint chair in machine learning, and also a Saatchi chair, very prestigious things here, in artificial intelligence for sustainable development. And she's involved in numerous other activities. Now, engineers, I'm told, they work in codes. They say things that ordinary people like you and I don't understand. But she has activities at IEEE, Computational Intelligence Society, and she chairs, that CIS monitoring program subcommittee there, and also on diversity, equity, and inclusion. So she's very involved in this IEEE activities, many, and that explains why she's sitting next to Prof. Maharaj. They're very selective engineers. And her PhD outstanding dissertation, is something that we are truly proud of. And she has worked in the WCCI in 2024. And again, she co-chaired the conferences going up to 2026. So she's very current in what she does. So she's not going to tell us stories here that, that are outdated. She has done a lot of work, PhD students, master students, and has been teaching for quite a while. And her research include hyper-heuristics, automated design of machine learning and research techniques, transfer learning, combinatorial optimization, genetic programming, genetic algorithms, and machine learning and optimization for sustainable development. And the focus areas on the work that she does in the NICOG. I told you how many, but you probably engineers will understand all of these acronyms. NICOG, and Prof. Pillay, has published two books, and 39 peer-reviewed journal papers, and 100 international peer-reviewed conference proceedings and papers, and 34 national peer-reviewed conference proceedings. She supervised master's students, 19, almost 20, and 8 PhDs to completion. That's very important, the completion part, the students must finish. And she was a team leader of the winning team for the 2019 UP PAL program, and has been awarded the UP Exceptional Achievers Award in 2024. So we go back a long way. I will not divulge the secrets of the PAL program and all the outstanding work there. So without any further, really, I would like to give an opportunity to take us to school. Prof. Pillay.
Thank you, Prof. Nelishia, for a very warm welcome. Thank you to everyone for attending. Again, thank you for allowing me to speak about something that I've been passionate about from grade 8. And I've been excited about this throughout undergrad, honors, masters, and that excitement until now has been totally on my own. Now, everybody else is also excited about AI, which makes it much more rewarding speaking about it. So let's just quickly check that this is working. It's coming through. So today I've left the codes behind. Everything is going to be, you don't have to decipher anything, but I do hope you do enjoy the talk. So what I'm going to speak about is, you've all heard a lot about artificial intelligence. It's grown a lot in the fourth industrial revolution. And are we at a point where we can actually use artificial intelligence to create artificial intelligence? And that's what the talk's going to be about. So just a quick outline. A number of different things are called AI in this day and age. So I'm just going to contextualize what I'm speaking about when I speak about AI. There's lots of work done with image processing that don't involve any AI that's sometimes called AI. So just what is AI in the context of what I'm going to be speaking about tonight. And my passion, when I first started doing AI, I worked with basically benchmark sets that the society that I was part of made available. And what's really exciting for me now is that I can actually use it in the real world. So the whole idea of AI for sustainable development, there's just so much done that I wouldn't be able to fit it in this time. So what I've done is I've picked some of my pet projects and some of the things that we've worked on with different people. And that's what I'm going to speak about a little bit under AI for sustainable development. And then creating AI. When we use AI to solve these problems, someone has to actually create that AI. And what does that actually involve, creating that AI? And then can we use AI to create AI? And then it leads to my final question, where I will eventually stop, and that is, can AI create itself? Okay. So first, what I'm going to do is I'm going to take you back and do some AI history. Where did this all start from? What was AI when it first came out? So in the 1970s, somebody called John McCarthy at an AI conference, which wasn't called an AI conference, it was just called a computer science conference, coined the term AI. So what was it all about when that term actually came up? It was something called search. For those that have done some AI, you would have heard about depth first search, breadth first search. They were things that weren't very intelligent, they didn't have any learning in them. But what is search? What does search involve? And why did people look at it, and how was it used in AI? So you were making your way here this evening to come to this talk, and wherever you came from, you always would try to find the best route. So the brute force way of doing that is you'd enumerate all the routes. You'd go through all of them. It can be painstaking. And then which one would you choose? You would choose the one that would get you here the quickest, right? So this is a brute force way in which we actually come to decisions. What search and optimization allows you to do is to get to that part of our entire space that we're searching, to get it to it quicker, to lead to where you want to, with ignoring parts that are not relevant. And this forms the basis of AI, basically. All the first types of AI systems that came up were based on this type of search. I think everybody heard about Deep Blue and Kasparov. That entire game-playing strategy was actually based on search. It was a search space that we did some pruning on, and let it run an IBM cause, and then we had it actually beating Kasparov. So what if we now bring in AI and we did search and optimization, how would it differ? You would start at some starting point. You randomly create a route that you think will work well. And then what you do is you do what we call some perturbation, or some movement to that route. You'll change maybe which route you're going, change maybe one point in that route. And then you'll check to see, okay, is that giving me a good result? If yes, let me go on. From there, perturb it a little bit more, go to the one with the better result, and eventually you get to there quicker. So the whole idea is we use two things. We use some knowledge of what is a better route, and we do some changing of it to get to a part of a search space that we can get to quicker, instead of looking at the entire search space and then taking the best. And that is basically the basis of search and optimization in AI. We're optimizing, we've got all these options, we've got this huge space that has all these options, but if we went through all of them, it will take a while to go through all of them. And what search and optimization does in a nutshell, it gets us to a point that we want to go to quicker without looking at that entire space. It helps you navigate through that space, and it uses two things. It uses some type of movement to move through, so something that moves you to the space. But the second thing you need, actually you need this first before you decide to move, is how do you know which direction to move in? And those two things combined form the basis of the first AI systems that we've actually had. But of course, since then, things changed, and what was missing was you had basic knowledge. You had a little bit of knowledge. Okay, what makes one route better than the other? The time that it takes to complete that route. That was all the knowledge you had. But if you took the search and you now wanted to diagnose a disease, or you wanted to, if you wanted to give somebody some advice as a clinical psychologist, for example, is that knowledge going to be enough? And that's where there was the whole idea of bringing in knowledge and knowledge-based systems. So instead of just that little bit of domain-specific knowledge, we bring in more knowledge. And that knowledge people took from experts. So first of all, when AI came out, can we use the search to beat people at games that people are thought of to be intelligent? So there was a lot of work with chess. The other thing is, can we use it to prove math theorems? A lot of work was done with that using search as well. But now, can we emulate an expert? And that was the next era of AI. Can we take the expertise of a doctor, a clinical psychologist, and can we then use that to get AI to converse with people in the same way? And that's essentially what knowledge-based systems was, and knowledge-specific. So we build in expert knowledge. And now I'm going to introduce you to Eliza, the clinical psychologist, and there's two reasons for this. Because I want to show you what AI was without learning and how AI actually works, the early day AI. Has anybody come across Eliza? Okay, so Eliza is a clinical psychologist. Anybody wants to ask Eliza anything? Prof. Miraj, anything you want to ask Eliza? Okay. They say, how are you? Okay, let's see what Eliza says. Why are you interested in whether or not I am? Okay, so you can see it's very, there's no learning in this. This is a straightforward pattern matching where what we did with knowledge-based systems is we took scenarios, we took human scenarios where people would ask things, then we'd match what somebody's typed in, and then we'd say, okay, then this is the response you give. Anything else we should ask Eliza? Anyone? How old are you? Okay. She's taking a while saying, would you prefer if I were not? So you can see that is a typical system without learning in it. Okay, so this is the early AIs. And you must know expert systems died very quickly because all they had in them were expert knowledge. They had cases. You would speak to doctors, you'd get that information. If a patient has this and the symptom, that's what you respond to. If from a psychologist, if you had this symptoms, diagnose it in this way. So that was one of the things that was actually missing in AI systems, is the ability to learn. It could only take things that you gave it, it could combine that with search in some way and try and solve problems. And that led to this exciting era which made AI known, which we're all very excited about at the moment, is the whole idea of machine learning, of getting AI to be able to learn. And that's where we've now had the difference between early work and more recent work. So the three main areas of AI in terms of machine learning is something called reinforcement learning. So with reinforcement learning, you take a typical environment like this. I'm looking at you. Based on your responses to me, I'm going to act in a certain way. If I say something and you're not looking good, I'll quickly change what I'm saying, or I'll rephrase it, and that's what reinforcement learning does. So reinforcement learning, you typically take an environment, you throw actors in it, and then your agents decide what to do next, based on what response you're getting from the environment. So it's very, very popular. It's not computationally expensive, and that's what reinforcement learning does. So people have heard a lot about deep learning, and deep learning use neural networks, and I'll speak about that a little bit more just now. This type of learning is the most popular. It's machine learning. We call it supervised learning. It basically learns the way we learn. So how do we learn? We make mistakes, and then we learn from the mistake. If you don't make the mistake, you're not going to learn from it. And I always tell postgraduate students, why are you worrying? Our computer scientists are wired to be perfectionists. If you don't crack it, and you don't break it, and you don't make it work 100%, you've done something wrong. You can't think like that when it comes to research. So that's basically an example of supervised learning. You get it wrong, it doesn't work. You find out why it doesn't work, and then you learn from that. And that is what happens with supervised learning and machine learning. And that is how we build supervised learning into AI. And the last one, and the advantage of the last one, is basically a variation of supervised learning. Supervised learning is expensive in that you need those experiences. You've got to get that data from somewhere. And we know how difficult it is to get data and get the right type of data. So that's the challenge with supervised learning. Usually you've got to also do what we call is annotate that data. So for example, if you want the system to learn when somebody has COVID or somebody doesn't have COVID, you've got to go through all those data sets, and you've got that information has to be in there. So the advantage of unsupervised learning is you don't need annotated data. It learns in an unsupervised way. And a lot of the work that we are doing are moving towards unsupervised learning now for that very same reason. So that's just AI in a nutshell. And just to give you an example of where we'd use supervised learning, suppose we wanted to do some disease diagnosis. What we'd do is we'd have to get information of people that have that disease, and also information from cases where people don't have that disease. And that's always the challenging one when we deal with health, is getting the cases where somebody doesn't have that. We'd put all that into our learning or training system, and that particular AI technique, whether it's a neural network, whether it's a support vector machine, whatever machine learning technique it is, will actually learn from that data. When it learns from that data, it will then produce a model. And that's the model that we use for disease prediction. Now, I'm sure people have heard about biases in AI and have been worrying about biases at AI. They happen if you stop at that point. If you stop your learning at that point and you only go out with that training model, that trained model, you have a problem because it may not be generalizing well. It's only specific to those things, the knowledge that you trained it on. So what you always have to do, and this is very important, is testing. You test. It may not work well for certain cases, and you test on a different set of data that you trained it in. So you'll take a set of patient information from a set of patients that had certain demographics, etc., for both those people that had diseases and didn't have that disease. You'll apply your ML technique to it, you'll get out a model, and then that loop must continue until you get to a point where it's trained well enough to generalize well enough. If it's trained on data that represents a particular sample of patients, then your system is going to be biased because it's biased to what it's trained on. And that's one of the other challenges with supervised learning. So that's just AI in a nutshell, just to more or less set the foundation for the other things that I'm going to chat about. So I'm going to go a little bit further with the search now, because this is how the field's developed. Remember we spoke about the routing idea, where you'll start off with the route, you'll make some small change to it, and then you'll lead to another route, and you'll make another small change, and you'll lead to another route, and then you'll eventually get to a route that will actually be the best route for you to get here. So that is what we call single point search. You start off at one point, you do some perturbation. Now, those points that you're looking at can be any solution that you can think of. So it may be drone routing. You're routing out your drones to take a particular path. It could be a schedule for lectures. So each of those dots could represent anything that you actually want to solve, any problem that you want to solve. So you could randomly create an initial solution, so randomly put together all the cities that you're going to visit on a route, or randomly put together a lecture timetable, and then you make little perturbations, and the search then directs it based on how well the next solution is, candidate solution, and you carry on in that way, and you avoid parts of the search space that you don't need to go to by just having some operator just make minor perturbations. When there's an improvement, you simply accept it and you move on. So that's a very simple something we call single point search. But what gets more exciting, as AI developed, it moved from single point search to something called multi-point search. So why should we look at one point at a time? What if we look at a set of points? We capture areas in the search space, we look at a set of points, and then we move from one set to the next. And we do that using some perturbation. And this I'm mentioning now because we're going to look at it in more detail later on. So the idea is our optimization techniques move from sets of points, from one set to the next. And then eventually we get to a set of points that has the solution that we actually want. Okay? And we stop at that point. And that's been an extension of working from that single point. We now call this multi-point search. And there's a very exciting algorithm which I started off when I did my PhD. It's based on Darwin's theory of evolution, that actually we take an analogy from Darwin's theory of evolution and use it in this multi-point search, which I'll speak about a little bit just a little later in the talk. Okay, so that's just an overview of AI and what I'm going to use when we look at now using AI for sustainable development. But before I go to that, I just want to speak about sustainable development a little bit of the work we've done in sustainable development. And there's lots done. So I'm sure most people are familiar with the 17 United Nations Sustainable Development Goals. And AI has played quite a crucial role in trying to achieve those roles. I mean, the one which is a challenge is equality, because when you build in the AI, it also poses the challenge of there being inequality depending on the infrastructure that different people have. So that's one that's a bit difficult to attain. But we've played with different sustainable development goals. We've used different AI techniques for different things. We've come up with some new techniques. But the three that I'm going to focus on this evening, because they have projects that I was quite excited about and things that we've worked on and we've enjoyed working on, innovation in industry, health and well-being, and of course education. Being in education myself, that's one of the areas that I'm going to look at. And I've just chosen some pet projects that I'd like to speak about. So thank you to our multi-choice colleagues for attending. So a lot of what I'm speaking about in innovation industry is work that we've done with MultiChoice. So MultiChoice sponsors my co-chair in computer science, and we do a lot of work with the broadcasting industry linked to using AI for broadcasting. So one of the projects that we've really enjoyed working on was the whole idea of using AI to automate picking up thumbnails for thumbnails for movies, so automated thumbnail selection, and that we used a combination of both optimization and machine learning in for that particular project. A more recent one was video shorts creation, which extends that idea, so creating video shorts from movies for different movies. Also, this used optimization to drive the machine learning, and I'll speak a little bit about that later on. Recommender systems, we've done a lot of work with recommender systems. The latest one, which I'm quite excited about, is we've worked with what we call multimodal data and multimodal machine learning. So we've taken different types of data. So to recommend something to a viewer, we've taken information that you get from a typical decoder, but we've also taken images of different movies and combined both those ideas and used multimodal machine learning for recommender systems. I've mentioned routing problems, and we've done a lot of work with different types of routing, including drone routing, vehicle routing. Vehicle routing is where you have goods in the vehicle that can go bad. You could take that into consideration. So a lot of logistic work that we've done. And so with the logistic problems, we actually solve them using pure optimization. So the search that you've basically seen, those type of search techniques are used for optimization problems. The other work which we've also done with MultiChoice is, I'm not sure how many people are familiar with VMAF. So VMAF assesses video quality of movies, etc. And the challenge with VMAF is if you use different types of videos, then you actually need a different type of a set of parameters going in. So we've done some automated configuration of VMAF as well. So health and well-being, there's a lot of work done on health and well-being. My Fitbit, which I have on my wrist, there's some AI in there that's keeping track of everything to make sure I keep well. And it extends. There's AI that's used in nutrition. There's AI that's used in disease diagnosis. And a lot of the work that we've done is AI in disease diagnosis. So this work was very interesting. We tried to emulate a chemical pathologist, and we worked with the chemical pathology department at UP. And essentially, we took what a human chemical pathologist would look at like, and we automated the process of interpreting that. And it was basically for myeloma detection, and we came up with very good results that were competitive to humans in doing that. And that was straightforward machine learning. So we used straightforward supervised learning for that. Oral lesion detection. So here, again, we worked with the dentistry department at UP. And the whole idea was to detect lesions, and here we compared both supervised learning and unsupervised learning to see how that would work. And again, we got very good accuracies for oral lesion detection. Cancer detection, we've done a lot of work on that. We've just presented some work that we've done, and we've looked at different, with a lot of the machine learning techniques, they will work specifically for one disease. And you can't then extend that technique across diseases. So what we've done is we've taken different types of cancer. We took skin cancer, brain tumors, lung cancer, and we've played with AI techniques that could actually work across that and use a different way of learning in neural networks as well, bringing in the idea of the way we learn, where we learn easier things first, and then we build on that to get to more complicated things. Heart disease detection, so we've done a lot of work with that. I think in South Africa, diabetes and heart disease is they one of the most popular diseases that we have, so automating that. With COVID-19, we were able to do some detection that had 98% accuracies for COVID-19 detection. That was way back in 2020, when there was a challenge with COVID. And then diabetes detection as well. That's very, very big. So we've done some work with diabetes detection. Depression is quite a big problem. So we've done some work. There was actually a competition that was run nationally in South Africa for depression detection. So some of the work we did was, again, looking at depression detection. And again, what was very interesting here, we used optimization combined with machine learning to get good results. It was actually a competition, so to be competitive with the competition, we were able to use two techniques. Now, this is my favorite picture, and it tells a lot. I'm not sure how well you can see it, but you'll see there's an operating table, but you will see no doctor near the operating table. But you'll see the doctor sitting behind a machine at the back, and you'll see more than one doctor there. So this is Da Vinci. There's now the current version, I think, is Da Vinci 5. Da Vinci does robotic surgery. And basically, whenever I give AI talks, I get asked the question, but is AI not going to take over everybody's job? And this is a classic example of where you can use AI in a complementary manner. So what advantages is AI giving you there? The challenges that you will know from the medical field, the challenges that people generally have are tiredness, fatigue. When it comes to surgeries, vibration of my hand, I would never be able to do surgery. Thank God I'm a computer scientist. Vibrations of the hands, etc. So all of that contributes to that. But if you get an AI-driven system that can actually do that, it takes away those challenges. But you still see the surgeon sitting behind a machine, they're driving it. So no, AI cannot be used to completely take over our jobs in cases like this, but it's complementary. It helps overcome some of the challenges that we have, and it helps support us to achieve, and that is why I like showing. So unfortunately, we weren't involved in this project. I would have liked to be involved in this project because it was quite exciting to come up with something like this. The current version of Da Vinci actually has, basically, it uses AI to work out how much of pressure is actually being put on the skin, to actually reduce the pressure on the skin when operations are being, or when people are being operated on. So it's technologies advancing as we go on. So that's just some of the things that we've been doing, but also things that I've been excited about that would have been nice if we were involved in. Okay, the last one that I'm going to speak about is one that I'm very passionate about. This is why I did my PhD in AI, was to bring in AI into education. So my PhD was specifically on artificial intelligence in intelligent tutoring systems. So the whole idea of lifelong learning, you get asked the question, okay, but some skills are getting redundant now because of AI, but it's not because of AI, it's because of progress. So if you look at what's happened with computerization, when there was computerization, people lost jobs, right? New jobs came up. But I'm going to speak about that a little bit more under Education 4.0, but that's why we need lifelong learning. And how can we use AI to maintain lifelong learning? So with lifelong learning, when I graduate from UP and I graduate with my degree, my learning just begins. But that's just giving me the foundation and skills to learn more. But things are going to change with each look at what happened with the fourth industrial revolution. That was the biggest impact of things changing. As we move from one revolution to the next, the technologies we use, what we do in our specific careers are going to change. And that is why we need tools that can support lifelong learning. And yes, AI may make certain skills redundant, but can AI be used to actually maintain lifelong learning so we can, for one, identify the skills that we are going to use so we can do retraining in time so we reduce the amount of unemployment? And also, how do we support people in lifelong learning? So this topic, I better make sure I keep to the time. This is something I can run away with me. It's something that started off my journey with AI, is the whole idea of intelligent tutoring systems. I mean, you've seen it now with people using ChatGPT. You've seen what's happened in there to some extent. But intelligent tutoring systems brought together people from different backgrounds. It brought together computer scientists. It brought together cognitive psychologists. It brought together a number of people. And the whole idea behind an intelligent tutoring system is that it can tutor people in the way that a person could tutor someone. So what makes it special when you have your own personal tutor? They tutor you based on your deficiencies that you may have in your knowledge. And that's what intelligent tutoring systems do. So I did a lot of work with intelligent programming tutors. We worked with the Center for Augmentative and Alternative Communication at UP, where we rolled out an intelligent tutoring system that could be used for speech therapists throughout South Africa, students that were studying to do speech therapy. It's quite exciting. I'm not sure if anybody's heard of Jill Watson. Her name should give it away. So Jill Watson is a teaching assistant at Georgia Tech, but she's basically all AI-based. And she is able to answer queries with a 90% accuracy, and that was before ChatGPT. So now they've included a ChatGPT module in her, and now she's even better, right? With all the knowledge that's in ChatGPT, which is about 10 trillion words that it's been trained on. So people can see what's happening. So intelligent tutor systems uses AI. More recently, it's building in machine learning. It used to use a lot of basic reasoning and optimization, but it's now building in machine learning to actually provide individualized tuition. This promotes lifelong learning, because you can learn in your own time, in your own space, without having to have someone right there or make an appointment to see someone. And this can also help when there's a change in skills, when there's a skill shift. You can actually use something like this to tutor, but also just to provide digital support in tertiary educations or secondary education or primary education as well. They've also been used in schools. Automated assessment, there's a lot of work being done on automated assessment. I mean, at our university, we've got, in engineering, we've got automated markers for programming. In computer science, we have a similar thing. There's lots of work on automated assessment, and there again, if you look at it, automated essay writing or marking of essays when they're written. So if we look at that, again, what are we doing? We're trying to help reduce the load of someone that's a lecturer or professor in terms of providing support in terms of marking. So educational data mining, another area of this is also called learning analytics, and we've done some of this where we've used optimization rather than machine learning, because one of the challenges with machine learning is that it's a black box technique. It doesn't tell you how it arrived at its conclusion. But the whole idea of educational data mining is to actually give students an idea of what could potentially happen in the future, identify those students that may have some problems, and then provide support before they fail or before they drop out. And that's what the main ideas behind educational data mining is. At UP, we have education innovation that actually uses different machine learning techniques for this purpose to actually do this. But that's all finally linked to Education 4.0. And if you look at what Education 4.0 is trying to achieve, it's trying to do two things. It's trying to sustain lifelong learning by using these emerging technologies that come out. But in addition to that, and what's very important, is to try and use techniques like AI to predict where we'll have a change in skills and where we need to upskill in time so we reduce unemployment, for example. And that's part of the entire learning process. So that's where I'm going to stop when I look at the different sustainable development ideas that we've worked with, etc. Now I'm going to look at, can AI create AI? So from what I've said so far, any thoughts? Can AI be used to create AI? So before I go into looking at that, I'm just going to quickly go through what it involves if you had to use AI. So if you look at those sustainable development problems that we solved, what did we use? Two of the main techniques that we used were supervised learning, and that's using neural networks. We used neural networks in particular. And the second technique we used was a search technique, an optimization technique, a multi-point search technique that we had based on Darwin's theory of evolution, which I'll speak about a little bit more now. But what does it actually involve? If you want to take an AI technique and you want to actually use it to solve a problem, what would you have to do? So the first one I'm speaking about is something called evolutionary algorithms. So the whole idea behind Darwin's theory of evolution is you start off with a population. It's not your best population yet, but as you move from one generation to the next, you improve that population. And what drives it? The fitness of that population, right? So the idea is as you move from one population to the next population, your elements of your population or your members of that population become fitter and fitter. So that's the whole idea behind Darwin's theory of evolution. And that's what evolutionary algorithms do in AI. So I spoke about optimization techniques, I spoke about multi-point techniques, and that's essentially what an evolutionary algorithm is. It does multi-point, so you remember our whole search space of roots, and we now want to actually restrict the search to certain areas that will then lead us to the best route. So we look at multiple points at the same time, and we base it on what Darwin's theory of evolution did. So if you want to look at the fitness of a route, what do you think the fitness of the route would be? It depends on what you want to achieve by the route. Do you want a quicker route? Do you want a lower cost in petrol? That would be the fitness of a route. So the fitter route will be one that will achieve what you wanted to achieve. So if you look at all those spots there, those spots represent different routes. Like we spoke about previously, you do some perturbation. But before you do that perturbation, something has to decide where you want to go to in the search space. And it's your fitness that decides that. Your fitness actually directs you as to where you're going to go to. What actually takes you there is that perturbation that you're doing. So we'll make some changes to the route, we'll swap things, we'll take two routes and cross them over. We'll do something to then get us a next set of points. And that set of points is usually different from the first set. You may have some duplicates. And then we continue in that manner. We'll then work out the fitness, maybe the shortest cost for each of them, shortest route in terms of cost. We'll take those, we'll then apply our operators to move to another part of the search space, and then we'll get a next set of points representing different routes. And then we'll continue in this manner. And each time we'll have a different set. So each of those different set of points represents different generations in Darwin's theory of evolution. So normally you start off with generation 0, where you'd randomly create your routes. You'll then work out how good they are in terms of the time it's going to take you, their cost. You'll choose the ones that have the best cost, use them to do some perturbation to them, get your next set of points, and you'll continue in that way. So each of those little circles with circles in them represent a generation, and each generation is meant to be better than the next. So that's using Darwin's theory of evolution. Eventually, you'll end up one, and that's with your route. The advantage of this is you don't have to look at every single route in the search space. You're moving from one little area of points to the next, and you get what you want quicker. So this type of optimization is used a lot. In some of the examples that I spoke about, they're actually used to solve the problem directly, but a lot of the work we do, sometimes they're used to actually come up with designing a technique like a neural network. So, but if you wanted to use something like an optimization algorithm, a search algorithm, what would that involve? So you'd have to decide things like how many points you want to look at as you go from one set of points to the next. What do each of those points represent? How to calculate the fitness, what you're going to use, there's maybe more than one option. How do you decide? So I've called them parents. Parents are the things, the points that you're selecting, that you're applying the perturbation to get your next set of points. So how are you going to do that? What operators are you going to do to move from one set of points to the next? How many generations, or how many of those little circles with points are you going to run this for, etc. So these are the different things that we actually, sorry, let me just go back one. So these are the type of decisions we make. We make these as humans. For those that have played with it, you'll know that these decisions aren't easy to make. And in order to actually make these decisions and know what to do, you've got to understand what an evolutionary algorithm does. Otherwise, you won't know these are the decisions you make. And this is where the challenges come up. So if you're somebody that wants to solve a problem, you know you've got a set of images. From those images, you want to work out whether somebody has pneumonia or doesn't have pneumonia. What do? You want to use, or you have a set of schedules. You want to see which is the best schedule for lectures or for exams. You don't want to have to go and learn about what a genetic operator is, and you want how many points you've got to have, and what selection you've got to do. And that's where the challenge is coming now, and that's where the bottleneck is, where you've got people that are non-experts that actually need to know these type of things to actually use the techniques. And the whole idea is, can we actually use AI to do this for us? So someone that's a non-expert basically says, okay, I want to predict pneumonia, I've got chest x-rays. Firstly, which technique do I use? Do I use optimization or do I use machine learning? That the system actually works it out for you. Then how do I actually design the technique? That happens in the background for you. And that's the whole idea behind AI, is creating AI. Can we actually do that? If we now go and look at supervised learning, we look at machine learning instead of optimization, the most popular technique used for that is neural networks. So our minds are full of neurons. We're actually using our neurons right now. I'm using them when I'm speaking to you. They're firing. Hopefully all of them are firing well. And the whole idea behind neural networks is neural networks are taking an analogy. It's basically a mathematical model of how your brain works. And the advantage of a neural network is, like our brains, we process things in parallel. And the whole idea of people taking an analogy of a neural network and using neural networks to solve problems is so that you have that parallel processing embedded in it. Now, you'll notice for a lot of the things that machine learning using neural networks are good for are things that we actually do as what we call low-level processing things. So identifying things, sight, anything audio, those type of things neural networks are usually good at. But what happens when you use a supervised learning technique? What do you need to know? First of all, and this is usually our biggest challenge when you're actually trying to learn, is getting data, getting the right data, and getting it in the format that you want to get it in. So the first thing is actually getting that data. Once you get that data, you then put it into your neural network learning technique that's going to do something. But there's certain things that you need to decide when you're using that neural network. The first thing is, which neural network do you use? There are a number of different neural networks. There's just a straightforward artificial neural network. There's bidirectional associative memory. More exciting in these days are all the deep neural networks with convolutional layers in them. So first of all, which neural network do you use? Also, how many layers should you have in your neural network? How many nodes should each layer have? So these are all the things you actually need to know when you're creating a neural network. And the thing that does the magic in the neural network, that does the learning, is something called an optimizer. So your optimizer is actually learning from that training data, is learning patterns in that data to then go and recognize more general problems later. But that optimizer also has some things that you've got to specify. How quick do you want to learn? You have a learning rate that you're learning at. From that neural network, we go through the same steps that we did with the supervised learning that I showed you earlier, because we're looking at a supervised learning model. You get your neural network that someone can now go and take and use. So for example, you can take that neural network model, and it can go and create clips for you, or it can create thumbnails for you, or it can predict a disease for you. And then we go through the same step where we test it, we make sure it works well, and that goes back in. But there are a number of decisions that you're going to have to make to use this neural network. The very basic one is, which neural network do I use? Then what are the components of my neural network? There's a number of exciting new optimizers that do different things, that learn in different ways. One's called Adam, there's stochastic gradient descent, backprop. Which one do you use? So when it comes to using a neural network as well, what do we have to do? There's certain decisions that we've got to make to use it. So before we even start looking at the architecture, which neural network are you going to use? Number of layers. If you're looking at convolutional neural networks and deep learning and deep neural networks, there's different types of layers. So how many of each type of layer do you actually need? What are the number of nodes per layer? Different parameters for your optimizer that's going to do the actual learning and create the model for you. The learning rate. Like we learn, I said when we learn, we've got to go wrong, and when we go wrong, we learn from that, we rectify the error, and that's how we learn. So what do you use to actually assess the error? What do you use? Our neurons fire at certain times. We need something to emulate that. Which function do you use for that? So each time you go through the training data, we call that an epoch. Each time you're learning from the training data, it's an epoch. How many of those do you put in? So can you see, again, it's expert knowledge that you need. So if you've got someone that just knows they want to solve a problem, you have to have some knowledge of neural networks, right, to actually do that. And this is what we're trying to get away from. Also for computer scientists to do this, the amount of time it takes to parameter tune these things. My colleagues will actually tell you that. It's actually laborious for us, both for the search techniques and for the neural networks. And for that reason, we've asked the big question, can we actually get AI to do this for us? So AI for AI, there's a lot of work done on this. There's a whole area called AutoML, which is automated machine learning. But what I've done is I've just taken some case studies that we've worked on in our research group, and I'm going to share that with you. A lot of the slides you saw before on sustainable development and the work we've done with sustainable development, a lot of this work was actually used for those examples. So we basically used AI to create those AI to solve those problems. So if you look at AI for neural networks, there's work done now where we use search techniques to come up with the design in terms of the number of layers, the number of nodes. There's a whole area called neural architecture search, where search is used just to actually come up with this for you. Work out the learning rate, decide which optimizer needs to be used, even decide which neural networks needs to be used for the particular problem. Work out the optimizer parameters. We've also done work, so these activation functions and these loss functions, usually humans come up with, researchers come up with it. So we've done some work where we can use search as a technique called genetic programming that will actually come up with the right activation function and loss function for you. to take that load off the person that wants to use it. The most exciting work we've done now, which just finished in 2023, and a student is extending this now going on to 2024, it's work that we are doing also with multi-choice, is the whole idea of multimodal learning models. Can we actually decide which techniques to use for multimodal learning when you're learning from more than one type of data and how to combine them? And that's some work that we just finished off in 2023, where we took both image and we took what we call quantitative data, which is text data, and from combining both of those, we actually then decided, we used AI, we used search to decide which techniques to use, what parameters to use for those techniques, and how to combine them. So this we are now extending to actually come up with the techniques, to use AI to actually come up with those techniques themselves. So then if we look at search and the work that we've done in search, coming up with determining how many points you're going to have, how many runs you're going to run that for, how many of those little circles you're going to have, what operators you are going to use. All of those, we've used search to actually find that out for search. With a lot of the search techniques you use, you create an initial point, or you create a set of multiple points. How do you create them? Usually a human has to come up with that technique. So we've done work where we've actually used optimization and search to actually come up with those techniques to create that initial point that you're going to start searching from. Because that point is very important, because you could lead to not getting what you wanted from having started off at the wrong point. So that is extremely important. I spoke about fitness, and we said, okay, if you're routing, you're going to look at the shortest cost. But for some problem domains, it's not that easy to work out what your fitness function should be, or what you're going to use to drive fitness. So we've actually used search to actually come up with those functions as well to drive the fitness. Then creating new operators that actually do the moving, that allow you to move from one point to the next. When we move through a search space, we need some perturbation to get to the right part of the search space. But what do you use for that? Usually as humans, we've got to try different operators, we've got to come up with operators, but we've used search to actually come up with that as well, both in terms of genetic operators and move operators. And the last thing, ChatGPT has now been used to come up with new search algorithms. So people have put in prompts. So what people are doing now, they're not using the AI to automate the AI. They're using the AI to automate the prompts to ChatGPT. And those prompts are then going in. And recently, one of our capstone conferences that we had in July, we've had papers presented where ChatGPT now is actually coming up with these search algorithms. Okay, so if we ask the question, can AI create itself, we're actually at the point where AI is creating itself. The challenge is to get that out for a non-expert to use. Can we now package that in the way that the way you go and buy a word processor or some accounting software, can you actually just go and get a package off the shelf that you say, I want to do disease diagnosis, I want to actually do COVID prediction, I want to get routes sorted out, I want to get schedules sorted out, this is the data I have, and that package then solves it for you and actually gives you the solution. So we need to get to the point of getting these techniques out of the laboratory where we're using AI to create AI and get it out there for someone that may not be an AI expert or a computer scientist to use it. Okay. So I will stop at that point.
Prof. Nelishia, I think all of us want to thank you for what I would call a very authentic, non-artificial, but very intelligent. I think that's all the important stuff for being a human.
And there were no codes, Prof. Masia.
There's no codes. We could all understand it. It's a topic that's complicated, and it's a topic that's actually often quite emotional for many people, and for good reason, because you look at various things and you say, well, you made it much more simple for some of us, part of it, and you also highlighted that there's other stuff that we never thought of, like AI creating AI, and suddenly we thought what the problems are, now we heard what they really are. Or maybe solving problems that we didn't even think about. So thank you very much for this. Thank you for highlighting it. And we are thankful that you are our colleague, because it's better to have you on our side than not. Thanks for that. Now with that, ladies and gentlemen, now it's your chance to ask the questions. So we've got a few minutes for questions. We've got a roaming microphone. And if you can just sort of put up your hands, I was told, please don't use the microphones on the desks. We've got a roaming one. Otherwise, it doesn't pick it up on the recording and so on. So if you can please indicate if there's questions from the audience. As you can see, you can ask the questions and you will get a human, authentic response to that.
I haven't generated it. The one thing I wanted to mention, a number of my images were actually AI generated so that I could ensure that they were public domain. So I actually just put in my terms into a generator and it actually produced the pictures.
So we'll look for the human-created art also next time. Please.
Nelishia, thank you very much for that presentation. It was really insightful. I just wanted to mention about the Da Vinci. You know that we do have it, hey?
Oh, no, I didn't know that we had
Okay.
it. Oh,
I want to
excellent.
tell everybody.
Oh, so I need to come and play with it.
The company moved it to the Faculty of Health Sciences and it's placed at Onderstepoort. So you can come and play around.
Oh, excellent.
And we'd love to play with you.
Thank you. That's very exciting.
Thank you very much for that. We need to highlight the toys that we've got. Always important. Any other questions? Question?
Yeah, once again, thanks a lot for the chat. It was really informative. So just on the thought of AI creating itself. Now, from what we know, ChatGPT, it's leveraging, obviously, information on the internet. I want to get your thoughts on to what degree is the AI going to be getting any new ideas when it's trying to create itself? Is there a bottleneck there too, in the sense that there's only so many ideas that people have thought of?
Yeah.
And to what degree, or maybe are we seeing the possibility that these different combinations are creating insightful new ways of designing the AIs? Right?
Okay, so I'm going to speak about one technique in particular because this has amazed me and it also amazes my students. So anybody that's had me as a lecturer in honors, you know I teach a module called genetic programming. And that module, or that technique, genetic programming, we use a lot for this automated design. And what is very unique to us and what always surprises us, so the way it works is based on Darwin's theory of evolution, but it actually comes up with programs. So it actually creates, the whole idea is you're working with a search space of programs that represent those points that I've showed. So the whole idea behind it is you move from one generation to the next and you're creating new programs and you use that program then to create a solution. It has come up with things that we actually have not thought of. So we've done some work with it. I spoke about creating a lot of the work in what we call discrete or combinatorial optimization. If there's industrial engineers here, you'll know what I'm speaking about. With a lot of that work, what happens is you have to have the right initial point to apply these search spaces, these search techniques to these optimization techniques. And we've used those algorithms to come up with those initial points. And it's actually outperformed anything that a human could actually do, that we came up with manually. The other challenge we have with things like that are heuristic is, depending on the technique you're using, the combination of the technique and the operator you're using, those have to go hand in hand. But as humans, it's not possible for us to come and think up with every single operator and technique combination that will work for different problems. And to come up with also the operators you use are specific to a problem. And that we've done some work where we've actually come up with the operators themselves. So I had a student that was doing neural network design, neural architecture design, and he actually came up with a genetic programming technique that produced the operators for the optimization technique to use to design the neural network. And of course, it was a problem that humans couldn't crack because they couldn't come up with the right crossover operator. So yes, in some ways, it is coming up with things that we may not have thought of. It's just because of the way these stochastic techniques work. The question you ask of where it may get saturated and you may get to a point where it's coming up with things that are not right, that's the other part of the search space. So the search space is huge. There's parts of the search space that you don't want to go to. The challenge is always measuring that fitness and measuring it correctly and finding a way of doing that correctly. Because if that's not accurate, then you will not end up with things that work well. And that's been the challenge. But we've now also been trying to use AI to do that.
Interesting. Other questions? We've got one, please.
Professor Pillay, thank you for your amazing presentation. So I'm a little bit more focused on the legal side of things, and especially AI in military decision making. So we see that military, officers are using AI to identify weapons, to identify objects, individuals, collateral damage. Is there truly a space for AI to identify it? Because we know that commanders who have been on the battlefield, they struggle to make these decisions. There are so many different circumstances that need to be taken into consideration. Is there truly a safe space for AI or not?
So there's a number of things I want to say, and they're all coming to my mind, and they're all going through at the same time. So we did a study with veterinary science where we were looking at dysplasia in Labradors. And some things that the human eye couldn't pick up, the AI was able to pick up. So it's going to be something that's complementary and something that has to be overseen to see what it's doing to guide it. The whole idea of working in a particular environment where you have different types of data, that's growing very, very quickly. So you want to bring in audio, you want to bring in visual data, basically the things that we do with our senses, right? The vision that I have now standing in front of you and speaking to you. And I know one of my students, when they were writing about multimodal learning, it says it's like somebody public speaking. You want to hear, you want to see, you want to bring in all the details together. And I think that's what you're speaking about on a field. So I would think, yes, that AI could be used. It would have to be used in a way that does some type of multimodal learning, but it would also you'd have to actually, when it learns, there'd have to be human input to assess how well it's doing, and possibly human input in the learning process when it's actually learning using AI.
Thank you. Another question. Question there.
Thanks, Prof, for that good lecture that we had. Two questions that I have. First one, with AI, there is a lot of computational complexities involved. So when AI creates AI, what are the challenges that you have? And then the second one is the bias. How do you, resolve the bias when AI creates AI?
So the first one, we've been through different phases with that computational cost, and it's exactly what you're saying. So we started off, when we use optimization techniques to create different AI, to use the optimization techniques, and then we try it out on the actual, so each time we work out fitness, for example, we run that AI technique that we're designing to work out what it is. And that is very expensive. So when we did things like using search to design neural networks, we'd have GPUs and we'd have CPUs. We'd have an architecture that combines both. But we've actually moved away from that now, and we're actually learning in real time. So as the neural network is now, and this is just something that's very recent, it's just happened within the past year or so, you could say 2023 to 2024, internationally, and with what we're doing with our group. So we actually now have a feedback back loop. So while your neural network is running, or while your search is running, at that point we are designing on the fly. So then that reduces that bottleneck of coming through from the, to run everything together. But this is not it's not a problem that's just specific to us, it's an international problem, and there's the whole idea of surrogate models. So where you have bottlenecks that are causing computational cost, we are actually coming up with surrogate models that can estimate things. So that your biggest cost, computational cost, comes with evaluating things. I said when you're moving in a search space, there's operators that move you, but then you've got to decide when you're moving and why you're moving. And to do that assessment, that's where the bottlenecks are. So there's a whole group internationally that's working on coming up with surrogate models that do those estimations. So the first thing we did was we threw computing power at it. We bought all these servers with GPUs and CPUs, but it's still not enough, no matter how many of them you have. So the next step was to actually find more intelligent ways of actually doing this. Then your second question was about the bias. And so the bias, we've been playing with techniques, and that's also something that wherever we come up with, we look at bias. One is the training. So the idea is to try and see if we can get techniques when we get our data to do processing on the data to see how representative our data is. And sometimes it involves a little bit of learning, to do learning on a smaller scale that won't be that computational intensive to try and eliminate data biases. So the one way is getting the right data to make sure that you're representative. But that's not always possible, because if you look at a lot of the work that we're doing with health, the data is imbalanced. You're not going to get, and that's what gives you biases when you have an imbalance in the data. So what we've done now is we're coming up with techniques that deal with bias. So that's what I've just been communicating to you about today. That's one of the students is working on that. So one way around it is just sometimes it's not possible. The other way around imbalances of data and having things that bring in bias is the whole generative AI. So we've done work where we didn't have enough data of, again, it was veterinary science. We had images for every Labrador that had dysplasia, but those that didn't have dysplasia, how do you do that? So, but also with the data that we had for those that had dysplasia, it wasn't enough. So generative AI to generate data, but you don't have data the reason you usually have bias is you don't have the data in your training. So can we also use generative AI to do that?
Thank you. We've got a question here.
Hi, thanks. In terms of AI for AI, then the application area, say industrial engineering, like AI for system engineering or industrial engineering, would that be a potential sort of interim step before you get to generic AI for AI? So your domain knowledge of the user of, say, industrial engineering needs that domain knowledge to ask AI to generate an AI for an application.
I hope I've understood you correctly, and if I don't answer correctly, please just direct me. So the idea here is if you come along and you have an industrial engineering problem, but you don't know about what a search technique is, you don't know about what optimization is, we find some way in which you pose that domain-specific knowledge, and the AI system basically will select the algorithm that needs to be used and will configure it and design it, and then will give you feedback, and then based on your input and how well your problem's being solved, then relook at the optimization. So that's the basic idea. I'm not sure if that was what your question was. So the practitioner that's actually using it will not have to worry about what a learning rate is, what an optimizer is, how many layers you need, what's a convolutional layer, etc. All they'll need to know is this is the problem I have to solve. This is what I want. And we want to get to the point where you can actually just give this to a system and it will do it. It's going to be made up of different components. There's an area that I didn't speak about, which is quite a big research area in my field, is the whole idea of algorithm selection. You have a problem you want to solve. How do you know which is the right algorithm to solve it? Do you want to use machine learning or do you want to use optimization? And there's a lot of work being done on using search to work out which is the right algorithm to use. So it should actually start from that point, and then once it's worked out the algorithm, go through, do its configuration, its design, etc. So that's our pipeline that we're hoping to get out at some point.
Good, we've got a question there.
Okay, thank you, Prof, for an amazing talk. So I'm going to come a bit from the technical side. In essence, the truth is everybody only got to experience AI when ChatGPT was released. So a lot of us who work in research and all of that, we've experimented with far more and so, but for mass markets and for the human race got to really experience AI, and that's why the hype went sort of like up when ChatGPT came out. So while on the topic of AI, building AI, I was hoping that we would get to a point whereby you tell us a bit about AGI and how we are moving towards the roadmap of building towards AGI, and that ChatGPT is actually the tip of the iceberg. So ChatGPT has its advantages, it has its disadvantages, but why was there the hype when ChatGPT took off? It was because people could relate to it. A lot of the stuff that we've been doing, I remember when I was doing my PhD, I'll ramble on and no one was in the least bit interested in what I was saying because it's the way I was presenting it. So just to deal with that part first, the way that you get people involved is you appeal to what they need and you appeal to how they can relate to it. And I think this is a lot, as computer scientists, this is what we do all the time. We work in our own little labs, we work on the technical side of that, and then we actually get to a point where we don't share it, but people don't even know what's going on, and we've got to put it in a context that it's actually appealing to people and it's of benefit to people. So the whole progression that you're speaking about and how we can get to the point that we want to get to that particular point, there's a number of things that we need to do along the way. So we as scientists and people that are technical, we develop the techniques, but we need to find a way of bringing in other people and bringing in the human factor in part of that so that is developed with them. And that's exactly what happened with ChatGPT. What did they do? They collected information from people and then found the basis that was appealing to people. So we need to bring that factor in, and it needs to be on different levels, because how do we actually make someone that's out there that doesn't know about it? We need literacy programs in place. We need to put that in place. But another challenge is infrastructure.
So if you look at during COVID, to achieve what we want to achieve with that overall goal, we all at different levels. And the SDG about inequality worries me a lot, because we are solving all the other SDGs using AI, but it's also increasing that inequality gap. And a lot of it is to deal with infrastructure. So some countries during COVID had sufficient infrastructure to have nurses that were robots in hospitals so that the nurses don't get affected, but other countries weren't. So how do we actually ensure, just even within our country, that we actually maintain that infrastructure so we can actually achieve that overall goal that you are actually speaking about? And then to also have a culture of lifelong learning. To go. A lot of people are afraid about AI, but why are they afraid? Because there's that literacy gap that we've got to bridge. I think at some point we started an AI society on campus, student society, was to actually try and bridge that gap and see if we can take it out to the public to actually bridge that gap. So I think once we can find a way of getting that information out there, working with people, we will achieve that more, but there's also the idea of infrastructure. I think one thing that works well, and we can see it in South Africa, is the Center for High Performance Computing. Computing power is expensive, linked to your question, and the only way that we've been able to do our research is because there's now this centralized entity in South Africa that makes high-performance computing available to all of us. And that is basically the way to go, to try and provide that for people, and then to use that to develop in the direction that then supports everyone when we are growing in the direction that we want to go to.
Good. We've got, I think, one last question here.
Okay. Thank you, Prof, for the presentation. You mentioned that one of the reasons you engaged in a study on AI was because of the grade 8 passion on teaching and learning.
Yes.
So I just had a thought when you were talking about AI for AI, and I had a thought as an academic myself, how can we use AI for AI to enhance teaching and learning? That's just my thought.
Yeah. Okay, so thank you. That's a very important question. So there are different ways, because if you're looking at teaching and learning, there are different gaps. The one way is, how do we use AI to help the learner learn and get to where they need to get to? But at the other end, how do we help the people that are educating to bridge the gap with using technologies and lifelong learning that they need to be able to educate? So I always get asked the question, should everybody learn programming now to do AI? And my answer is no, because there are different skills that different people have. If I'm a computer scientist, I need to know how to program because I want to create the AI. But if somebody's a lawyer, do they need to know how to program? No, they need to know how to use AI in their career. So in terms of teaching and learning, the AI for AI, the one area is to develop tools automatically that help both the educator learn, but also how you can actually use that to then teach these things, these new technologies to students. And the one area is, how do we decide what we bring into curricula? How do we put things into curricula? Also from the lifelong learning side, UP does this with enterprises. Can we actually capture some of these tools and have enterprises courses to help bridge that gap in terms of learning? Because what I want to know as an educator in my field, what do I teach to my students and how do I use it in my career? Because that's more important than me going to learn to program and create a neural network. So that's just my input on it. Other people's opinions may differ.
Last question.
Thank you, Prof. And thank you for the good presentation. My question actually goes with regard to EDI, equity, diversity, and inclusive. Yeah. Fine. AI for AI, where we're generating, using AI tools to generate another tool. But when you look at it in the society, how do we use it to ensure that our community, our life, our environment is safe? I give you an example. Just yesterday or 2 days ago, we know by November, US is going to an election. Yeah. Now, there is now this issue of using somebody's pictures that is in England to generate information over the social media and saying that that's the person, that particular person is actually supporting one of the presidential candidates. So when you look at that, that is an EDI issue. Yeah. So how do we make sure that whatever we actually generating or we're promoting, there is that issue of that inclusiveness, equity, and diversity is reduced to a barest minimum?
So that's a very important question. I see three different things. The one is, what are we doing as a society to deal with that? The one is where we need governance for that, and the last is using AI again for that. So the first one, Prof. Masia read all my IEEE stuff out, and one of my jobs in IEEE is diversity, equity, and inclusion. So what we're doing as part of the Computational Intelligence Society, which is basically an international artificial intelligence society, we are now putting together project proposals that we're putting together to get people to actually use computational intelligence to solve problems in society that are linked to that. So, if, for example, bias detection. So as AI researchers and AI communities, we need to actually get projects like that up and running. And we're trying to fund 2 projects from 2025 that will deal with that as our subcommittee on equity, diversity, and inclusion. That's the first part. The second one, and this one's really important because you cannot stop someone from doing what they meant to do. And the idea is when you're using AI to design AI, can you design AI that actually has these built into them? So when you're doing that design and you're doing the automated design, do you have, when you're creating your fitness function and you're using automated design to create that fitness function, do you create one that takes bias into consideration? So you're basically using the AI. We ran some proposals. We had a prospective student coming in that wanted to do a PhD. We ran some proposals to turn it in, and turn it in told us this whole thing's been generated via ChatGPT. So how did Turn It In pick that up? It used AI to pick that up. So again, we can use AI, and AI in the design is very important, and that's what the IEEE Computational Intelligence Society is doing. How can we build AI into our systems to actually cater for this? So if you're dealing with a system that's doing human resource management, what AI can you use to create, or you use AI to create the system in such a way that it doesn't have the human biases that humans normally have in it? The last one is the whole governance question, because you need governance at different levels, because you can't actually control what a human does, but if you have certain rules at certain levels, and I get asked this question over and over again, and so it has to be a national initiative, and you need people at different levels, so you need people at government level, but even within a particular institution or a particular industry, you need to have your own rules that you have governing the use of AI. And that's important, because there's so much that the AI can do to prevent that, but you can't predict human nature. So there's rules that also, I see it as a 3-pronged solution.
Now it's the last question. If it was AI deciding, it was a different output.
It may stop generating just now.
Thank you very much for your presentation. It was quite insightful. So the first thing I want to ask, I've got 3 questions. They're related in a way. I don't know if you wanted to be provocative with your title by saying, can artificial intelligence create itself? Yeah. Because it's an inanimate object, isn't that so? Yeah. And itself meaning perhaps it has some human qualities to it. So, that's the base opening statement. The next thing is, if you look at AI, and if we say ChatGPT perhaps was at the pinnacle of that, where does ChatGPT fit in on this Turing test, the test of humanness? Right? Be very interesting in that. So that's just the 2 opening. The other thing is, I think the lady on the corner raised it as well. I think a lot of your talk was around AI being a tool, I think a tool for good. Can you comment on AI from a notorious perspective in terms of ethics, in terms of the extent of it, and can we control it for the less desirable people who want to use it for bad? Can it become a threat to civilization?
Okay, so the first one, the itself was just it was to provoke interest, like you said, so so we all know that it is inanimate, and unfortunately everything built in AI is put in by humans and it learns from us, so it was exactly what you said. Your second question, sorry, again, was? ChatGPT. So yes, we should test ChatGPT on the Turing test, and quite frankly, I think it will pass the Turing test. We were able to pick up very easily because we know what is put in a research proposal. It depends on who's looking at the other side of it, right? Like those proposals I spoke to you about, we know what understanding would come through and what understanding wouldn't come through. And that is why we could pick up this was just generated text that had come through, and that is why we ran it through a tester. So it depends on who's on the other side of that door, looking at what's being put through, and depends on your knowledge of the field and what you're looking at. But in a Turing test in certain contests, I think it would possibly pass it. In terms of AI for bad, so fortunately I haven't come across any examples for AI for bad, and I hope that may be because there's good regulation of it. The only AI for bad that may come across is possibly hacking and things that you do see coming through sometimes where systems are being broken to by other computer security, breaches in computer security. That's a challenge. But it's like anything, right? Like the internet, like anything that you have connected with a network. Any network that you're connected in any way, and you can use some type of intelligence, not necessarily artificial intelligence, you can even use human intelligence to create problems. So we have to have safeguards in what we put in, and of course the safeguards have to be increased. The challenge is sometimes we only know what the problem is when it happens, and we know the way we have to then find a solution to it. It goes back again, for me, to governance and challenges that you put in and putting in laws in place, but those are not going to be foolproof. There's still going to be some things that are going to have to go wrong first. And when they go wrong, then we say, no, we've got to be careful of it in this way.
Thank you very much for that. I think I will tie it up with a comment at the International Deans meeting early this year where the whole question also was about, yeah, but what about all the unethical stuff that students can do now? And the general response was, listen, we don't need AI to be unethical. We can do that very well as humans. So please don't blame the AI for now everybody is unethical. We did it very well without that. There's fortunately also good human stuff that we did without AI. Thank you very much for the responses to the questions, Prof. Nelishia. We really appreciate that. I would like to invite Prof. Mosia to do the final thanks and closure. Thank you.
Thank you. I think she deserves another round of applause. She's our secret weapon here. You know, when I go to these places where I don't understand anything that's being spoken about, I ask her very nicely. She's always nice to give me all these clever answers. But I just want to thank you now. The night is still young. I see quite a number of executive members here this evening. It makes a huge difference. I see the interest. You hardly get 4 in a room. And some senior people here, directors, HODs, you know. This was really interesting. We hardly get this Senate full, but she's done it again. So thank you very much for those insights, Prof. It's very instructive to many of us. I was particularly interested in your choice of Eliza as a clinical psychologist and the answers in particular, because, you know, I worked a little bit, well, not a little bit, for many years in health sciences. And the most difficult people can find in any profession are psychologists and psychiatrists. If you have them in one room, forget it. You'll never get any answers. So there are no answers there, I understand. But, and listen, gentlemen, we have come to the end of this expert lecture. It was really something that we can keep on learning, even some of us who are quite old now. Yesterday I had a meeting with one of our colleagues, helped me with a presentation, you know, and spent many hours on this thing. He says, no, I'm just going to ask ChatGPT and then it'll do this thing for him, like this guy. So this morning he gives me this thing, I'm like, yeah, now I see what you guys do to us, you know. And thank you very much, ladies and gentlemen. Have a good evening. I'm told there are some refreshments outside, courtesy of the Dean. And yeah, it's the Dean. You pay for that, right? Yeah, so Thank you very much and have a good evening.